Hello, good afternoon and salam sejahtera to all of you. So today we will do e-revisions physics SP025 slot 2. Teknik menjawab soalan PSPM 2018-2019. So for this slot, there are 5 lecturers involved and we will do discussion together with you all. So I would like to introduce myself. I am Dr. Wong and this is Puan Nadia. This is Puan Zaina. This is Cik Fiona. And finally is Encik Sam. So let's start the first questions. So questions number 1. Figure 1 shows two charges. Q1 equals to positive 8 microcoulomb and Q2 negative 6 microcoulomb placed 4 meters apart. So the first questions A. Calculate the electric potential at point A and B. B. Calculate the electric potential difference between point A and B. C. Determine the electric field at point A. So let us start with questions number 1A. Calculate the electric potential at point A and also B. Okay, let us start with questions number 1A. Calculate the electric potential at point A and point B. Okay, so for the first questions, if you refer back to the equation list, this is the equation list for chapter number 1. So we must find out which equation is suitable to answer these questions. So because we want to find electric potential, so equation number 5, V equals to KQ over R, is the equations that we want to use to determine the electric potential at point A and point B. By using the equation list just now, we noticed that the electric potential, we need to use V equals to KQ over R. So if you refer to point A is influenced by 2-point charge, okay, which is Q1 and also Q2. Okay, so V equals to KQ1 over R, where the distance between Q1 and A is 3 meters, whereas KQ2 over R, where Q2 and point A, the distance, we need to use theorem Pythagoras. Okay, so we need to calculate RA with Q2. Okay, so the distance between them is equals to 3 square plus 4 square root. And we notice that we will get 5 meters. So we substitute inside 5 meters. Okay. So by substituting the charge Q1 and Q2, Q1 is positive 8 times 10 to the power of negative 6 and the radius is 3. Okay, and then for Q2 we substitute negative 6 times 10 to the power of negative 6 and the radius is 5. Okay, so finally we will get VA equals to 1.32 times 10 to the power of 4 volt. Okay, next, electric potential at point B. Okay, so electric potential at point B, for this point, there is also 2-point charge Q1 and Q2 that give influence. So we need to find, by using KQ over R, we need to find the radius first. So for Q1 and point B, the distance we need to use R point B with Q1. Okay, is equals to 2 square plus 4 square and then square root. So we found out that the distance between Q1 and B is 4.47 meter. Okay, so we get 4.47 meter and Q2 is equals to 2 meters. So we substitute inside 2. So again, we substitute all the charges and the radius inside, and finally we will get VB equals to negative 1.09 times 10 to the power of 4 volt. Okay, so for these questions, there are 4 marks. Okay, so how can you score these 4 marks? Okay, so the first one, when you do the substitution, you will get 1 mark. gantian 1 mark. And then your answer with correct unit vote, you will get another 1 mark. Jawapan with the correct unit 1 mark. Similar for B, if you do substitution correctly, gantian, you will get 1 mark. And then the answer with the correct unit, negative 1.09 times 10 to the power of 4, and you must write with correct unit vote. So you will get another 1 mark. Okay, so for 1A, you will get total 4 marks. Next, we will go to questions number 1B. Okay, so calculate the electric potential difference between point A and also point B. So just now we already found VA, which is 1.32 times 10 to the power 4 volt. And VB, we already found negative 1.09 times 10 to the power of 4 volt. So now we want to find the electric potential difference. Okay, difference meaning perbezaan. Okay, between point A and also point B. So what should we do is we can use VA minus VB equals to 1.32 times 10 to the power of 4 minus negative. Okay, so you just substitute all the value VB, negative 1.09 times 10 to the power of 4, and you will get 2.41 times 10 to the power of 4 volt. Okay, or you also can use VB minus VA. Okay, so this also we accept. Okay, if you write VB minus VA, we also accept, where you take B minus A and then you will get negative 2.41 times 10 to the power of 4. Okay, so for this one, you will get 1 mark for, okay, so either one, okay, either one. So you will get 1 mark for gantian jawapan unit yang betul. So you will get 1 mark. Okay, so either you can use VA minus VB or you can use VB minus VA. Okay, next questions number 1C. Determine the electric field at point A. Okay, so before we start to do the questions, first we must refer back to the equation list. Okay, so from the equation list 1 until 9, which equation is suitable for us to determine the electric field at point A? Yes, okay, because this is a point charge, so we use equation number 3, E equals to KQ over R squared. So from the equation list, we notice that at point A, okay, we must use KQ over R squared. Okay, so at point A, we assume that there is a positive charge at here. So positive and positive Q1, positive, it will repel. So it will go downward and we label it as E1. Okay, so next one is point A and also Q2. Point A is positive, Q2 is negative. So our point A, it will attract to Q2. So we label it as E2. Okay, so this is the diagram that we will use to find the solutions for the electric field. Okay, so based on this diagram, okay, we need to use 5 steps. So the first step is you need to determine the value for E1 and also E2 first. Okay, we need to find out the magnitude of E1 and also E2. Okay, so after we determine the directions, just now E1 going downward and E2 is going upward, okay, above the x-axis. Okay, so now step 1, you need to determine E1 and E2. Okay, so E1 is equals to K, the constant is 9 times 10 to the power of 9, and Q1 is 8 times 10 to the power negative 6, and distance between A and also Q1 is 3 meters, so is equals to 3 square. And finally, we get the value for E1. The magnitude of E1 is equals to 8 times 10 to the power of 3 Newton per coulomb. Okay, so next, we also need to find E2. So E2 is equals to K, 9 times 10 to the power of 9. And if you refer here, Q2, I no longer put negative because we only want the magnitude. Okay, we only want the magnitude. So we don't need to substitute the negative as we already determined the directions of E2. Okay, so you don't need to put negative. If you want to put negative, this one you must modulus. Okay, you must modulus. And finally, we get E2 equals to 2.16 times 10 to the power of 3 Newton per Coulomb. Okay, so this is the magnitude for E1 and also E2. So this is our step 1. Okay, step 2 is you need to resolve it. Okay, you need to resolve it into X and also Y component. Okay, so before you resolve it, you need to find the value, the angle first. The angle first, where the angle is equals to, okay, let's just find the angle first. Okay, so here is the angle theta. Okay, so from the triangle we use tangent theta. Okay, we use tangent theta equals to 3/4, and we found out that the angle theta here is equals to 36.87 degree. So you can substitute inside here 36.87 degree. Okay, then only we resolve. So if you follow E1 is only going downward, okay, in Y axis. So X axis is equals to 0, but Y axis you will get negative 8 times 10 to the power of 3. So why I put negative? Because negative indicate that the direction is going downward. Okay, for E2 we can resolve it into E2 X component and also E2 Y component. So E2 X component we write as 2.16 times 10 to the power of 3 cos theta. And for Y component, because it's going upward, so it's positive 2.16 times 10 to the power of 3 sine 36.87 degree. So after that, X and X component, we add on Y and Y component, you will get negative 6.7 times 10 to the power of 3. So this is step 2. Okay? Okay, next one, step 3 is we need to determine the magnitude. So magnitude, we use theorem Pythagoras because we have, just now we found our X component and also Y component. So we can use theorem Pythagoras to find the resultant, the magnitude. Okay, so after we substitute all the value, you will find out that the E resultant is equals to 6.92 times 10 to the power of 3 Newton per Coulomb. Okay, so next one is we need to determine the directions of the resultant, the E resultant at point A. So by using tangent theta, we substitute EY over EX. Okay, our tangent theta equals to EY over EX. Okay, so you find out that the angle or the directions for the electric field at point A is 75.5 degree. Okay, and you will get negative. So negative 75.5 indicate that is below positive X axis. Okay, so if I write 75.5, you must also mention below positive X axis because the negative here indicate that it is below the positive X axis. Okay, so how can you get 8 marks for these questions? Okay, so 8 marks here. Okay, I write first. Okay, how can you get 8 marks? So the first mark is gantian to find E1. The second mark is gantian to find E2. Okay, so as long as you substitute all the value correctly, you will get gantian 1 mark for E1 and also E2. Okay, next one. If you substitute correctly X component 0 and 2.16 times 10 to the power of 3 cos theta, so you will get also 1 mark for gantian. And also Y component, you substitute correctly, you will get also 1 mark for gantian. Okay, so next one is if you use this equation, you substitute all the value inside, Okay, so you will get concept 1 mark. Okay, because you know how to use the theorem Pythagoras equations to find the magnitude. And finally, for this one, if you get the answer 6.92 times 10 to the power of 3 Newton per Coulomb, you will get gantian, jawapan. With correct unit, you will get 1 mark. Okay, and then if you substitute EY over EX, you also get 1 mark for the gantian. And finally, jawapan with correct unit, you get 1 mark. Okay, so either you write 75.5 below positive x-axis, or you also can write theta equals to negative 75.5 degree. Okay, so negative here indicate that the direction is below positive x-axis. Also, we consider correct. Okay, so for these questions, total is 8 marks. Okay, total is 8 marks. So that's all for questions number 1, 13 marks. So next we will proceed to questions number 2. Questions number 2. Figure 2 shows 3 capacitors C1, C2, and C3, each 12 microfarad connected between point A and also point B. So 2A, calculate the effective capacitance. B, if the potential difference across AB is 9 volt, calculate the stored energy. So 2A, calculate the effective capacitance. So before we solve these questions, we can refer back to the equation list. So which equations do you think is suitable to solve these questions? Yes, equation number 11 and equation number 12 is the equations that we use to solve to find the effective of the capacitance. So equation number 11 is the equations we use when the capacitor is connected in series. And equation number 12 is the equations when the capacitor is connected in parallel. Okay. So next. So we know that C2 and C3 is connected in parallel. Okay, so we try to simplify C2 and C3. Okay, so C2 and C3 are connected in parallel. So we use the equations number 12, where C23 equals to C2 plus C3. So by substitute C2 12 micro plus C3 12 micro, we get C23 equals to 24 microfarad. So after we simplify it to become C1 and also C23. Okay, so after that we will get C1 and also C23, okay, in this circuit. So what should we do next is C1 and also C23 are connected in parallel. Okay, so we find C23 and C1 connected in series. So we use the equations C effective 1 over C effective equals to 1 over C23 plus 1 over C1. Okay, so by substitute the value, C23 is 1 over 24 microfarad and C1 is 12 microfarad. Okay, so we will get 8 microfarad. So for these questions, there are 3 marks. So how can we get these 3 marks? So the first mark given if let's say you find the first one, C2 and C3. Okay, so this one, if you substitute correctly, you will get 1 mark. Okay, and then next one, if you substitute correctly to find C effective, you also get 1 mark. And finally, if you get 8 microfarad, find the C effective, so you will get another 1 mark. Jawapan with correct unit. Okay, so total 3 marks. Okay, so next we go to questions number 2b. If the potential difference across AB is 9 volt, calculate the stored energy. So please refer back to the equation list. From equation 10 until 14, which equation do you think is suitable to find the stored energy? Yes, it's equation number 13, where U equals to half CV squared, U equals to half QV, or you can use U equals to half Q squared over C. So it depends on what are the informations that you have. So just now we already found C effective, where C effective just now is 8 microfarad, and now it's given 9 volt. So the potential difference is equals to 9 volt. So we can use U equals to CV squared. Okay, so by substituting the value where your C is equals to 8 microfarad and V equals to 9 volt, so finally you will get the energy stored is equals to 3.24 times 10 to the power of negative 4 joule. So for 2B, only 1 mark is given, where this you will get gantian, jawaban, U is unit, you get 1 mark. So meaning that if you substitute all the correctly, and also you get the answer with the correct unit joule, then you will get 1 mark for these questions to be. So questions number 2 already finished. Let us proceed to questions number 3. So questions number 3. Calculate the number of electrons that flow in a wire if it carries a current of 2 ampere for 5 seconds. And question number 3B is a 2.5 kilowatt heater is connected to a 220 volt power supply. So first one, calculate the current and resistor in the heater. B2 is the coil of the heater is made from a wire of cross-sectional area 2 times 10 to the power negative 7 meters square, and the resistivity is given 1.1 times 10 to the power negative 6 ohm meter. B3 is they ask you to determine if the voltage of the power supply is then changed to 110 volt. Initially it's 200 to 220, so now we change to 110. So calculate the new power output of the heater. So let us go to answer 3A first. So for question 3A, they ask you to calculate the number of electrons that flow in the wire if the carries a current of 2 ampere for 5 seconds. Okay, so if you refer back to the equation list, equations number 20 and 21 is the equations that we need to use to find the number of electron. Okay, so first we know that I equals to dq over dt and q equals to ne. So the number of electron. Okay, so if we combine these two equations, you will get the number of electron equals to I current times the time taken over the charge E. So by substituting the value, I is the value for the current. Okay, so it's equals to 2 ampere, and also T is the time taken 5 seconds, and then the charge is equals to 1.6 times 10 to the power negative 19. So finally, you will get the number of electrons that flow in a wire is equals to 6.25 times 10 to the power of 19. Okay, so for these questions, we have 3 marks for these questions. So the first mark is the concept. Okay, so if you know how to apply these two equations, and then you get N equals to IT over E, so you will get concept, you get 1 mark. And then you will get Gantian, substitution 1 mark. And then this one, the final answer with correct unit, you will get 1 mark. So 3 marks for questions number 3A. Okay, next, 3B1. So now they give you a heater, 2.5 kilowatt heater is connected to a 220 volt power supply. Okay, so by referring to the equation list again, okay, so find the current and also the resistor in the heater. So which equation do you think we can use to find the current and also the resistor in the heater? Yes, equation number 28, where power equals to IV, power equals to I squared R, or power equals to V squared over R. So it depends on what are the informations you have. Okay, so since now we have the power, Okay, we have power and we have V. Now we want to find current. Okay, so we can use P equals to IV. Okay, because we have P and V, so we can find I. So I equals to power over V, where power is equals to 2.5 kilo. So kilo we convert into power of 10 to the power of 3, and V is equals to 220. So finally we will get 11.4 ampere. Okay, and next we want to find the resistor. So V equals to IR. Okay, so we have V and I, so we can find the resistor. So the resistor equals to V over I, 220 over 11.4. So finally, you will get 19.4 ohm. So for these questions, there's 3 marks for this question. So the first one is gantian. If you substitute all the value correctly, you will get the marks for gantian. And then for current, 11.4 ampere, you will also get jawapan with correct unit. You will get 1 mark. Okay, and make sure unit is in ampere. And the last mark you will get is for resistor, where the resistor is gantian, jawapan with correct unit, 1 mark. So remember, unit is ohm. Okay, either you write OHM or you can use this symbol ohm. Okay, so again, for these questions, there is 3 marks for 3B1. So next we will proceed to question 3B2. The coil of heater is made from a wire of cross-sectional area 2 times 10 to the power of negative 7 meters square. So the first information they give us is the area, and the resistivity 1.1 times 10 to the power of negative 6. So they give you resistivity and they ask you to determine the length L. Okay, so by referring back to the equations, R equals to rho L over A, where we want to find L, so we need to rearrange back the equations. L equals to RA over rho. So by substituting all the information, so finally you will get the length of the coin is equals to 3.51 meter. Okay, so for these questions, only 2 marks given. So the first mark is the substitution, you will get 1 mark. And then the second mark is the answer with correct unit. So remember, must in meter. Okay, so 2 marks for questions number 3B2. Next, we proceed to 3B3. If the voltage of the power supply is then changed from just now is 220, now we change to 110 volt. So they ask you to calculate the new power output for this heater. Okay, so we need to recalculate back based on the informations given. So now our new V is equals to 110, and the resistor that we calculate just now is given 19.4 ohm. Okay, because we are using the same heater. Okay, but now the voltage we already reduced. We changed to 110 volt only. So we need to calculate the new power. Okay, so we use P equals to V squared over R. Okay, so V now we change to 110 square over 19.4. And finally, we will get a new power supply is equals to 624 watt. Okay, so for these questions also there's only 2 marks. Okay, so the first mark is gantian, substitution, 1 mark. The second mark is correct answer with correct unit. Okay, so remember for power, the unit is watt. Okay, so 2 marks for questions number 3B3. Questions number 3C. Figure 3 shows a circuit with the battery having an EMF of 12 volt and internal resistor of 0.2 ohm connected in series to 2 resistor 3.3 ohm and also 2 ohm. Okay, so from the diagram shows that we notice that this is actually a battery, okay, with the EMF of 12 volt, and 0.2 ohm is actually the internal resistor. And there's a two external resistor where is 3.3 ohm and also 2 ohm. So the first one, they ask us to calculate the current in the circuit, and number two, they ask us to calculate the terminal voltage across the battery. Okay, so by referring to the equation list back, which is the equation that's suitable to use to determine the current in the circuit? From equation number 21 until equation number 25. Yes, it's equation number 25. V equals to EMF minus IR. So we can find current by using EMF equals to V external plus V internal, or we can write the equation IR plus IR internal. So by substituting the value, EMF is equals to 12 volt, and the R external 3.3 plus 2, R internal 0.2. So finally, we will get I equals to 2.18 ampere. So next one, find the terminal voltage across the battery. So V terminal is equals to EMF minus IR. Okay, so we know that actually V terminal, we also can say this V terminal is the value V external. Okay, is equals to V external. So that's why we take EMF minus V internal. Then we will get V terminal or V external. So again, we substitute the EMF equals to 12 volt minus I 2.18 and R internal 0.2. So finally, we will get V terminal equals to 11.6 volt. So for these questions, only 5 marks. So the first marks that you will get if, let's say, you use this equation concept. Okay, and then substitution, you will get 1 mark. And then if you get the current 2.18 ampere, you will get another 1 mark for answer and correct unit. Next one, if you substitute the value inside correctly, you will get 1 mark. And finally, if you get the correct answer with correct unit, you will also get another 1 mark. So total is equal to 5 marks. So that's all for questions number 3.
Question 4a, figure 4.1 show the arithmetic field of 1.8 times 10 to the power of negative 4 Tesla is normal to an aluminium frame of dimension 60 cm times 85 cm. Calculate the magnetic flux through the frame. Before you calculate what is the magnetic flux, okay, you have to know what is the meaning by arithmetic field normal to an aluminium frame. Okay, as you can see here, the B is 90 to the frame. So we use formula 41, flux is equal to BA cos theta. As you know that B is the magnetic flux, A is cross-sectional area, and the theta must be angle between vector area A and B. So we substitute the value for B, 1.8 times 10 to the power of negative 4, and cross-sectional area is 0.6 times 0.85. We have to change in SI unit. And then the cos theta is cos 0 because the angle must be vector area A is always 90 to the plane and B. So the angle between vector A and B is 0 degree. So the flux is 9.18 times 10 to the power of negative 5 Weber. So the marks will be given for substitution 1 marks. For answer and unit, 1 mark. So the total marks will be 2. Next, 2 Roman. The frame is flipped so that it is parallel to the Earth's magnetic field in 2 seconds. So calculate the induced EMF. So this is the initial position where the angle is 0. Okay, what will happen if the frame is flipped to the parallel to the Earth's magnetic field? So as you can see that the theta will be changing. So initially you can see that the angle is 0 between vector area A and B. Vector area A and B. And then after the frame is flipped, so you can see now the angle between vector area A and B is 90 degree. So calculate the induced EMF. By using formula 41 and 43, we can see that first we know that the flux final will be 0 because cos 90 will present 0. Okay. The question asks you to calculate the induced EMF. The induced EMF formula is given by induced EMF is equal to negative d flux per dt. So you have to know what is the change of the flux. So the change of the flux is come from flux final minus flux initial. So flux final is 0 minus with flux initial. You have calculate in question 1 Roman. So 9.18 times 10 to the power of negative 5. So the change of flux will be given by negative 9.18 times 10 to the power of negative 5 Weber. So we substitute in induced EMF formula. So induced EMF is equal to negative d flux per dt. So negative times with negative 9.18 times 10 to the power of negative 5. We divided by 0.2 second. So we get that the induced EMF is equal to 4.59 times 10 to the power of negative 4 volt. So the marks will be given for concept 1 marks. For substitution, 1 marks. For substitution, 1 marks. And final answer and units, 1 marks. The total marks will be 4. Next, we proceed with question 4b. Figure 4.2 show a 0.6 meter long metal bar being pulled to the right. At a steady speed of 5.7 meter per second perpendicular to a uniform 0.7 Tesla magnetic field. The metal rails are connected to a 5 ohm resistor. The question asks you to calculate the magnitude of the EMF induced in the circuit. For the list of the formula, formula 44 is induced EMF by using metal rod. So induced EMF is equal to BLV sine theta. Then the theta must be angle between V and B. So as you can see that here B is direction is out of page and the V is to the right. So the angle between V and B is 90 degree. So substitute B as 0.7, L is 0.6 and the V is 5.7 sine 90. So you will get the induced EMF is 2.394 volt. Make sure you answer the question with final value in 2 or 3 decimal point. So this is mark for substitution, 1 mark, and the final answer and unit 1 mark. So they contribute to marks. Next, calculate the current through the resistor and its direction in the metal bar. Okay, as you can see that the metal bar is being pulled to the right. So here we have two methods to solve this problem. First, we calculate the direction of current by using analogy for Ohm's law. As you know that Ohm's law is given by V is equal to IR. But in this chapter, we use V as an induced EMF. So I will be equal to induced EMF divided by R. Induced EMF 2.394 divided by R, resistor is 5. So we get the induced current is 0.48 ampere. And then how direction of the induced current? Okay, you can use by using right hand rule, or we call it as dynamo rule. You can see that the right hand rule, we use the thumb as your V. And the second finger is for magnetic field. And the other finger, second finger, is represent induced current. Okay, now by use your right hand, so you can see that when the V is to the right and B is out of page. And you can get the direction of induced current is downward. Or otherwise, you can use Fleming left-hand rule by determine the direction of FB. The direction of FB always oppose the motion of V. So FB will be to the left. So FB to the left and the B is out of page. Out of page. And also you get the direction of I is downward. Or clockwise. How to get clockwise? Because the metal bar here showing the downward direction of induced current, you can rotate it until you get the complete cycle. So the cycle is clockwise. So the mark will be given substitution, answer and unit 1 marks for induced current, and answer for downward direction of induced current also 1 mark. So total marks for this question is 2. Next, for C. A solenoid of length 8 times 10 to the power of negative 2 meter and cross-sectional area is 5 times 10 to the power of negative 5 meter square contains 6,500 turns per meter length. Calculate the self-inductance of the solenoid. As you can see that the formula given 51, L solenoid is equal to mu naught N square A over L. But the question given you is 6,500 turns per meter length. So I have to rearrange this equation to make sure that the length is another length for this N power of 2. The length should be power of 2. And then how to reduce one length here? you have to substitute length in this formula. So you can see that the L solenoid will be mu naught is 4 pi times 10 to the power of negative 7 times with n over L power of 2. N over L power of 2 is given by 6,500. And then the length is 8 times 10 to the power of negative 2. And area is 5 times 10 to the power of negative 5. Why you have to write length here? Because you have to cancel length for this power of 2. Okay, so the solenoid is 2.12 times 10 to the power of negative 4 Henry. So the marks will be given for the concept here. You substitute this L to cancel off the another L here. Then for substitution and final answer and unit 1 marks. Question 5a, figure 5 show an AC source with a voltage of connected to a 100 ohm resistor is given by V is equal to 200 sin omega t. So calculate the RMS voltage. So we use the formula from this equation 54 and 57. So first you compare the equation of voltage with the general value is V is equal to V naught sin omega t. You can determine that the V naught is represented by 200 volt. So by using the formula 57, VRMS is equal to V naught over Z2. So V naught is 200 is divided by Z2. You get VRMS is equal to 141.42 volt. So the marks will be given 1. So next, calculate the RMS current in the resistor. So RMS current you can use formula 56. So before you get the RMS, you have to determine what is the value for I naught. So based on Ohm's law, V naught is equal to I naught times R. So rearrange the equation. So we get I naught is equal to V naught over R. So V naught is 200 divided by 100. So the I naught or peak current will be 2 ampere. And then substitute in formula 56. We get IRMS is equal to I naught over Z2. So I naught is 2 divided by Z2. We get 1.41 ampere. So the marks will be given for substitution and answer with unit. So next, calculate the average power delivered to the circuit. So as you know that power delivered actually is same to the power loss. The power loss is always relate with the resistor. So based on question 28 from chapter 3, we can relate this equation or this formula with the formula that we use in chapter 5. So here you can see that the power is equal to VI is equal to I squared R and also equal to V squared over R. But when we relate to the power loss, make sure that the V here is V across R. And also here. And then because we use this formula in chapter alternating current, so the source and current must be in RMS value. So I'm using the formula of P average is equal to I RMS square R. So substitute I RMS is 1.41 power of 2 times with resistor is 100. So we get power average is 198.81 watt. So the marks will be given for substitution here and final answer here. So next, 5B, a series of RLC circuit consisting of 35 millihenry inductor, 45 microfarad capacitor and 85 ohm resistor is connected to an AC generator of 150 volt and 60 Hz. Calculate the capacitive reactance. Before you proceed to answer the question, make sure that you know the AC generator here is actually 150 volt is represent VRMS. As long as the question is not state that the V is peak voltage, so we assume that its source come from a AC source, so should be VRMS. So calculate the capacitive reactance. So capacitive reactance is come from equation 58. So Xc is equal to 1 over 2 pi Fc. So substitute frequency is 60 Hz and C is capacitance is 45 microfarad. So micro is 10 to the power of negative 6. We get Xc is equal to 58.94 ohm. The marks will be given for substitution and the final answer. So next, calculate the inductive reactance. So inductive reactance is related with the equation 59. So XL is equal to 2 pi FL. So substitute frequency is 60 and L is inductor is 35 millihenry. Milli means 10 to the power of negative 3. So the answer for XL is equal to 13.19 ohm. So the marks will be given for substitution and final answer. So the next is impedance. So impedance is come from equation 60. So Z is equal to R square plus XL minus XC square. So because in this case XL is bigger than XC, so I'm proceed with the XL minus XC formula. So R square is 85 square plus XL is 59.94. So actually this is error typing 58.94 minus with 13.19 power of 2. So the value for impedance you get is 96.53 ohm. So the marks will be given in substitution and final answer 1 mark. So next, a series RCL circuit consists of 35 millihenry inductor and 45 microfarad capacitor and 85 ohm resistor is connected to an AC generator of 150 volt and 60 Hz. Calculate the phase angle. So the phase angle is come from equation 61. Phase angle is equal to shift tangent XL minus XC divided by R. So as you can see that the shift angle here is 58.95 minus with 13.19 over 85. So you get the phase angle will be 28.30 degree. So the marks will be given in substitution and final answer. Question 6a. An internal side mirror of a car is a convex with radius of curvature is 18 meter. Determine the location of the image for an object 10 meter from the mirror. As you can see that the question given the radius of curvature is means R, and then they said the convex surface means that R is negative. Determine the location of the image means that the question asks to determine what is V, and then the object is 10 meter from the mirror is U. So the related equation is 66 and 67. First, we determine the focal length for the mirror is R over 2 is equal to negative 18 is divided by 2 and equal to negative 9 meter. After that, substitute in the mirror equation. Rearrange the equation V as a subject. So 1 over V is equal to 1 over F minus 1 over U. So equal to 1 over negative 9 minus with 1 over 10. So V is equal to negative 4.7 meter. The marks is come from the substitution of the focal length, substitution for the mirror formula, and the final answer for V is negative 4.7 meter. So the question is contribute 3 marks. So V negative means that the image is virtual. So next is 6b. Show an object embedded in the solid glass with a hemispherical end of the radius 30 cm and refractive index 1.5. The object is 40 cm inside the glass. Calculate the image distance while the refractive index of the air is 1. So related equation is 69. N1 over U plus N2 over V is equal to N2 minus N1 over R. As you know that the object is starting from the glass, so N1 will be refractive index glass. And then the U is the object distance. Object distance must be come from the surface to the object. So the value is 0.4 meter. Plus with 1 over V. N2 is air and V is the image distance is equal to 1 minus 1.5. Is divided by R. R is the radius of the hemispherical. So we can see that the negative is represent the object facing the surface of convex. So that's why we put negative here. So the final answer will be V is equal to negative 0.48 meter. So the marks will be given in the substitution and the final answer with units. Next, 6C, a 2 cm height object is placed 7 cm from a concave mirror whose radius of the curvature is 12 cm. Determine the image distance. The height of the object is 2 cm. And the place is 7 cm is U. And the radius given is 12 cm. But the mirror is concave, so radius is positive. Determine the image distance V. So the related equation is equation of the mirror. So R is equal to 12. So focal length will be 12 divided by 2, is that 6 cm. And then substitute in the formula of mirror. So you will get V is equal to 42 cm. Positive for V is remaining that the V is real. So the marks will be given for substitution and substitution for the length. And final answer with unit, 1 mark. So the total will be 3 marks. So next, determine the image height. Okay, based on this, you can use the formula of 68 m is equal to hi over ho and also equal to negative v over u. So, magnification is equal to negative v over u. So, v is 42 and u is 7 cm. So, we get the magnification is negative 6. Negative 6 means that the magnification is magnified. And negative means that it's real and inverted. So, we substitute in the formula of hi is equal to m times ho because it's come from the rearrange of this equation. So, we get that hi or height image is equal to magnification times with height of object. So, magnification is 6 because we only take the value of what we call it the value of magnitude. Okay, so substitute 6 times with 2, so we get 12 cm. And how about characteristic of the image? Okay, characteristic of the image is magnified, inverted, and real. So the marks will be given for the magnification is gantian, means that substitution. And then for the height image, we get for gantian jawapan and unit lah. Substitution, answer, and a unit. So untuk characteristic of the image, substitute for 2 marks here. And you can choose other tools from these 3 characteristics.
Question number 7A. Orange light of wavelength 600 nanometer is incident normal to a diffraction grating having 3500 line per cm. The question 1, calculate the slit separation. For the question number 2, determine the maximum number of bright fringes that can be observed. And the question number 3 is, how can the number of bright fringes be increased? Solution. Given wavelength lambda is equal to 600 nanometer, diffraction grating n is equal to 3500 line per cm, by solution is equal to 3 times 10 power of 4. For the solution, the first question, for the calculate the slit separation by using the equation d equal to 1 over n, substitute the value of the diffraction grating n is equal to 2.85 times 10 power of negative 6 unit in meter. For the question number 2, determine the maximum number of the bright fringe can be observed using by the equation d sin theta equal to n. So that means n equal to d sin theta divided by lambda. Substitute the value of the n, the slit separation, and substitute the value of the lambda. So n can get the 4.76. So can focus the value of round of 4. So maximum the number of the bright fringes 4 times 2 and plus 1. So the total is 9. The question number 3, how can the number of the bright fringes can be increased? The answer is the decrease the wavelength or decrease the number of line per cm or increase slit separation. Question number 7B. Figure 6 show two paths of coherent lights from point A and B that produce an interference pattern at point C. Determine whether it is a constructive or destructive interference if AC and BC are 2.2 lambda and 5.7 lambda respectively. So solution for the 7B, path difference BC minus AC. So that means 5.7 lambda minus 2.2 lambda is equal to 3.5 lambda. So that means 3 plus half lambda. So therefore it is destructive interference. Question number 7C. Calculate the thickness of a soap film so that a 600 nanometer light incident to the film will produce constructive interference. Index of refraction of soap film is the 1.33. Solution for the 7C. Condition for the constructive interference by the using equation 2nt equal to m plus half lambda. So for the thickness, minimum thickness, so substitute the value of order equal to 0. Then substitute the value of the wavelength is the 600 nanometer. So the thickness minimum can get 113 nanometer. Question number 8. In a photoelectric effect experiment, light of frequency 1.15 times 10 power of 15 Hz strike a metal surface and electrons are emitted immediately. The work function of the metal is the 2.3 electron volt. Calculate the first question is threshold frequency. Question number 2, calculate the maximum kinetic energy of photoelectron. Question number 3, calculate the stopping potential of the photoelectron. For the solution, given frequency is the 1.15 times 10 power of 10 Hz and work function is equal to 2.3 electron volt. For the calculate the threshold frequency of the metal by the equation, work function is equal to Hf0. So by equation, rearrange F0 is equal to work function divided by H. Substitute the value of work function 2.3. Electron is the 1.6 times 10 power of negative 19 is divided by H constant 6.63 times 10 power of negative 34. So the answer of the threshold frequency of metal is equal to 5.55 times 10 power of 14 Hz. Then for the question number 2, calculate the maximum kinetic energy of photoelectron. By the equation, Kmax is equal to Hf minus work function. Substitute the value of the constant of H, 6.63 times 10 power of negative 4 times frequency threshold frequency 1.15 times 10 power of 15 is the minus the work function 2.3 times electron volt 1.6 times 10 power of negative 19. So the answer for the kinetic maximum is equal to 3.9 times 10 power of negative 19 joule. Then for the question number 3, calculate the stopping potential of the photoelectron. By the equation, Vs equal to Kmax divided by electron. Substitute the value of the Kmax, 3.9 times 10 power of negative 19 is divided by electron 1.6 times 10 power of negative 19. So the answer for the stopping potential is equal to 2.44 volt. Question number 9a. Calculate the speed of a neutron with the de Broglie wavelength 9 times 10 power of negative 11 meter. Then question number 9b, calculate the wavelength of the electron that has been accelerated across a potential difference of 100 volt. For the solution, question number 9, given the Broglie wavelength lambda is equal to 9 times 10 power of negative 11 meter. So the question number 1, calculate the speed of a neutron by the Broglie wavelength. By the equation, lambda equal to h is divided by mass times velocity. So rearrange for the v is equal to h is divided by mass times wavelength. Substitute the value of h, 6.63 times 10 power of negative 34 is divided by mass is the 1.674 times 10 power of negative 27. The lambda 9 times 10 power of negative 11. So the value of speed is equal to 4.4 times 10 power of 3 unit in meter per second. Then the solution for the question 9b, calculate the wavelength of an electron. By equation lambda equal to h is divided by square root of 2 mass of electron times potential difference. Substitute the value of the constant h 6.63 times 10 power of negative 34. Then substitute the value of mass of electron 9.11 times 10 power of 31. Substitute the value of electron 1.6 times 10 power of negative 19. Then substitute the value of the potential difference is the 100 volt. So that the value of wavelength is equal to 1.23 times 10 power of negative 10 unit in meter. Question number 10A. This question is the out of syllabus. To be continued, question number 10B. A 2 gram sample of radioactive iodine has a half-life of 8 days. Question number 1, calculate the decay constant. Question number 2, calculate the initial number of atoms in the 2 gram sample. Question number 3, calculate the activity of the sample after 2 days. The solution for the question number 10B, given half-life is equal to 8 days, mass of sample iodine M is equal to 2 gram, mass number of iodine is equal to 131, Avogadro constant Na is equal to 6.02 times 10 power of 23 per mole. Question number 1, calculate the decay constant is lambda. By equation, the T half-life is equal to ln 2 is divided by decay constant is equal to 8 days. Rearrange the equation. So, decay constant lambda is equal to ln 2 divided by 8 is equal to 8.66 times 10 power of negative 2 unit in per days. Convert to in second. The decay constant is equal to 1.003 times 10 power of negative 6 unit in per second. For the solution 10B, calculate the initial number of atoms by the equation N naught is equal to mass of sample ion divided by mass number of iodine times Avogadro constant. So that's mean substitute the value of mass sample is the 2 gram is divided by mass number iodine is the 131 times 10 the Avogadro constant 6.02 times 10 power of 23. So that's mean the value of initial number of atom is equal to 9.19 times 10 power of 24 atoms. The solution for the question number 10B3, Calculate the activity sample after 2 days. By equation, A equal to A naught exponent power of negative lambda times T. Rearrange is equal to lambda times initial for number of atom and not times the exponent negative lambda times T. Substitute the value of lambda in second. 1.00 times 10 power of negative 6. Substitute the value of the initial number of atom. 9.919 times 10 power of 21 times exponent power of negative lambda. Lambda is equal, decay constant is the 1.00 times 10 power of negative 6 and times 2 days convert into second. So that means 2 times 24 times 16 times 16. So the answer for the activity of sample after 2 days is equal to 7.75 times 10 power of 15 decay per second.